So welcome to our session on R programming. So let us slowly start our discussion. So yesterday we were discussing some concepts. We have seen the basic arithmetic operations we have discussed. Then we have also seen our basic functions like absolute function, square root function, like this we have seen. Basic functions. Like this you can also apply log function. All these functions are available for us. Now, then we were discussing about our data types we were discussing. So under data types we have seen a numerical data type for us. Then we have seen character data type we have seen. And we have also seen a logical data type we have seen. So all these different types of data type we have seen, and we have created these data types one by one. We have created these data types. Now, what is it we are going to do is, afterwards, we have seen how do you create your numeric vectors. We have seen how do you create your character vectors. We have seen how do we create our logical vectors. We have seen. Then we have also used some functions like class function, is.numeric function. And for conversion of our data type, we have used as.numeric function, as.character function, as.logical function we have used for conversion of our data types. We have used this. And then we have seen some more functions like cbind function, column bind function. We have seen binding our vectors into two columns. That is what we have seen. And then we have also discussed your functions like names function or row names function. And then we have also seen length function, append function. All these different types of functions we have seen. How to modify our data. All these things we were able to discuss. And then not only this, we have also seen our is.na function for checking our null values. Is.na. for checking our null values. Then we have also managed to perform imputation, that is, replace these null values with some other alternate modified value. We were able to do that. We were replacing that value with no. This we have done yesterday for some of our observations. So this also we have discussed. So remember all these functions. They are going to help us in our analysis. Now, what are the other things we are going to discuss? Let us try to understand with the help of some small examples. Let us try to discuss those things. So how do you subset your data? Subsetting operation. Let us try to understand this concept. So my underscore friends is a character vector for us. Let us try to check once. So you have all these values. Nicholas, Thomas, Jacob, and Jimmy. You have these values. And now, for example, if you want to select my friend who is in position number 2, if you want to select your friend who is in position number 2 first. So remember in R, yesterday we have seen the indexing is going to always start from 1. Indexing is going to start from 1. So this is 1, this is 2, this is 3, this is 4 for us. So we are going to select our friend who is in position number 2. So what is it you can say? You can say my underscore friends. In brackets, you can give 2. So in box brackets, you have to give. Whenever you want to subset your data, you have to give the information, the position number in box brackets. Whenever you are using any function, then you have to use your open brackets. So whenever you are subsetting your data, box brackets, whenever you are using any functions, then open brackets you are supposed to use. Now, press Ctrl Enter E. So what is the result we are getting? We are able to get our result, which is Thomas first. We are able to get our result, Thomas. And now, suppose if I want to select my friend who is in position number 2, same piece of code you are going to give. My friends in box brackets, you give 3. Press Ctrl Enter. Then it is going to give me the result of Jacob first. Jacob is in position number 3 first. So like this, you can subset your friends. It's a simple piece of code what we are writing here. Now, suppose if you want to select my friends who are there in position number 1 and position number 3, How are you going to select? You can simply say 1, 3. So it is going to give you the result of friends who are there in position number 1, position number 3. Nicholas and Jacob. This is the result what you are going to. So if you want to see also your friend who is in position number 4, you can say 1, 3, 4. You can give in this manner. One comma 3, 4. So now you have your friends who are in position number 1, 3, and 4. So Nicholas, Jacob, and Jimmy first. So this is what we have. Now, so we have seen selecting our friends in position number 1 and position number 3. This is what we have done. Now suppose if we want to select our friends who are in positions 1, 2, and 3. I want the list of friends who are there in all these positions. Then how are you supposed to say? You can say my underscore friends. And then in brackets, you have to say 1, 2, 3 for us. So it is going to give you all the friends who are there in your positions 1, 2, 3. So we can say control enter here. We can give control enter. So positions, friends who are there in positions number 1, 2, and 3. So this is what you can give. So if you want to know who are the friends who are there in positions number 1 to 4, then you can simply say 1 to 4 and you can press control enter. So now it is going to give you the list of friends who are there in all these positions. Position number 1, position number 2, position number 3, position number 4. So this is the information what we can get. Now, suppose if you are working on named vector, that means a vector which is having names first. Suppose if you are working like this, it is a named vector, all these numerical values, they are having names first. Now, if you say friend underscore ages in brackets, so then you are going to get, along with the name, you are also going to get what is the age of that friend, of that person. So press control enter. So it is giving us the result. It's saying Jacob 29 for us. So this is the value which is there in position number 3 for us. Now, if I say friend underscore ages, if I give 2, then I'm going to get the value that is there in position number 2. This value we are going to get. So in position number 2, I have Thomas and age is 25 for Thomas. So this is how you are subsetting your data. And now you are subsetting your data on a named vector for us. You are subsetting your data on a named vector. So this is what we are doing. Now, suppose if I want to exclude any friend, if I want to remove any friend from my list, how can I remove? So first let us take one example. What is the vector we are considering? My underscore friends. This is the vector. Now in this vector, character vector, I want to remove the friend who is there in position number 2. So therefore I am saying my friends, and in brackets I am giving -2. So negative indexing we have to do. So then it is going to exclude that person's name from your vector. So exclude that person's name from our vector. So now the friend who is there in position number 2 is gone. Thomas is gone here. So we are left with Nicholas, Jacob, and Jimmy first. We are left with these people. So that is how you can exclude, by giving negative indexing first. Suppose if you don't want to see Jacob, then I can say simply my underscore friends -3 if I say. I will be excluding my friend Jacob from the list. Jacob is gone. Jacob is gone from the list. Suppose if I want to exclude 2 of my friends from our list. 2 of my friends from the list. Then what you can say? My underscore friends and then -c 2, 4. So C yesterday we have seen. C is a generic function which will help you collect your values and then it is going to create a list. So I'm saying remove my friends who are in position number 2 and 4 from my character data, from my character vector. This is what I'm saying, -6. So exclude my friends who are there in position number 2, 4 first. Press Ctrl Enter. So now Nicholas and Jacob are remaining, and then we have excluded Thomas and we have excluded Jimmy from the list. Both of them are gone. Thomas was there in position number 2. Jimmy was there in position number 4. So this is what we have done. Now, what if we want to exclude our friends who are there in positions between 1 and 3? Suppose if I want to exclude my friends who are there in positions 1, 2, and 3, then how can I say? I can say my friends -c in brackets 1:3. I can say like this. So then it is going to exclude all my friends who are there in position 1, position 2, and position 3. This is what we are going to get. So now you can press Control Enter here. So now all the friends have been excluded except the friend who is there in position number 4. You have Jimmy. So only the output what you are getting is the last friend Jimmy first. So what is another way of doing this? Another way of doing this is you can say my underscore friends, and then you can say minus C, 1 comma 2 comma 3. So this is same as writing my underscore friends minus C 1 is to 3. It is same. There is no difference. Same output you are going to get. So let us cross verify. Let us cross check if you are going to get the same output or not. So press Control and here. So again we are getting the same output. We are getting the same output as Jimmy first. So output is matching. Now let us try some more examples. Now let us try to select some values using some conditions on a logical vector. Let us try to select some values. So what is that we are doing here? We are saying my underscore friends, check what is the output that you have. This is a character vector for us, my underscore friends. And then you have another vector what you have created, R underscore married. So press Control Enter. So this is a logical vector for us, R underscore married. Now you want to select only married friends from your logical vector. You want to select only married friends. Then what you are going to do? You can say my underscore friends, and then I want to select only those friends who are married. This is how I can write my piece of command. So if R underscore married is equal to true, check for this condition and return all those values. Return all those values from my underscore friends vector. That is what you're saying. So now observe, R underscore married is equal to true. So it has applied this condition. It has checked for this condition first. And now it is in a position to return those values where this condition is being satisfied. So R underscore married is equal to true is being satisfied in these two observations. So it is going to give you the result as there are two observations or two friends in my data set where R underscore married is equal to true first. So remember, whenever you are checking for any condition, you have to use double equal to. Okay. And whenever you want to assign values, then you have to give single equal to first. Checking for any condition. R underscore married is equal to 2. R underscore married is equal to 4. So whenever you are checking for any equal to condition, you are supposed to use double equal to sign. Whenever you are assigning value, then you can simply give a single equal to sign. So this is what we are supposed to understand. Now, let us check for some more conditions first. So now, let us try to apply some conditions on another vector, friend underscore ages. So this is a numeric vector for us. It has numbers. Now, this is our my underscore friends character vector. So what is the condition that we are applying here? We are checking for one simple condition, friend underscore ages. If it is greater than or equal to 27, give me all those observations. Give me all those names of my friends. This is what I'm saying. So check for this condition. If the age is greater than or equal to 27, then give me the names of those friends. Give me those observations where this condition is being satisfied. So let us try to apply this condition. Press Ctrl F. So now in two observations, this condition is getting satisfied. Friend underscore ages is greater than or equal to 27. So you have Nicholas and you have Jacob. So you are able to satisfy these conditions. You are getting the required result first. So that is how we have to check for some conditions. So we have applied some conditions on our logical vector, and now we are applying some conditions on our numeric vector. So it is working in both cases. So we are able to get the required result. So this is how you can check for some small conditions. Then let us take a look at some more examples. So we have seen RM function yesterday. So RM function is going to remove your objects or remove your variables, what we have created in our environment. So you can say RM and you can remove this value if you want. Remove this object what you have created. Have underscore child. So now there is a new function what we are going to experiment with, which is called as type of function. Type of. So I'm saying type of have underscore child. What do you think this result is going to give us? Press Ctrl Enter. So it is giving us the same result what we got when we have used our class function. So class function is also giving us the same result, and then type of function is also giving us the same result. So you can use any of them depending upon your choice. And then you can find out what is that vector what you have created. You can find out what is the type of that vector, what we have created. So this is what we have to understand. So now type of function we have seen, and then we have seen class function also we have seen. And then we have discussed some of the operations on how you are supposed to handle your missing values. This is what we have said. How are you supposed to handle your missing values? So now, for example, have underscore child is there. So now there are no missing values for us. So what is going to be this output of the code what we have written here? I'm saying each dot in A have underscore child. What is this output? It is going to check for any null values. I'm saying not equal to here. Then what is the output going to be? Something other than null values. You have to understand when you insert this not equal to sign here. What is the meaning? Something other than null values I want. So I'm saying give me non-null values in your data set. That is what I'm saying. So now apply that. What is the result you are going to get? That will be interesting for us. So now you see, it is giving us the entire character vector. What is the reason for this? Because there are no null values here. So it is giving us the information that all these are non-null values for us. All these are non-null values. So this is what we have to understand. So how can you better understand this code what we have written? I'll just show you. So let us create again this vector, and now you observe. What is the output going to be? Now if you give have underscore child, you have null values. You have null values in Jacob, you have null values in Jim. So now this output of the code what you have written is going to give you all the values other than null values. It is going to give you all the values other than null values. So let us try this out. Press Control Enter here. So now you see, it is giving us those observations which are not null values, which are other than null values. It is going to give us which are other than null values. Now, let us scroll down. So remember, all these operators can be used for comparison. What are your comparison operators? Less than, you can use greater than, you can use less than or equal to, greater than or equal to, if you want to check for equality condition. You can use two equal to signs. If they are not equal to, you can use this sign. For understanding, not equal to. Just now we have used. So we have said is.na have underscore child, then we are seeing not equal to null value and give me all those values. This is what I'm saying. So the result what you got is Nicholas and Thomas. This is the result what you got. Nicholas and Thomas. Yes and yes. Now, let us do some calculations with our vectors. So what are these calculations? First, we are creating one, a numeric vector. This time, what are the values that we are having? We are having 2000, 1800, and 2500, and 3000. This is the values what we are having. So create the salary vector. So we are creating. And now, so one way of assigning the names for your numeric vector we have seen yesterday, you can take the help of your names function. This is one way of assigning. So press Ctrl and T. So now we have assigned your names. So this is what we have done. We have assigned our names. So for all our salaries, $2,000, $1,800, $2,500, $3,000 per month, you have assigned names. So Nicholas, Thomas, Jacob, and Jim. So for your numeric vector, you have managed to assign your names. This is one method. What is another method? It is very straightforward. So assign your names to your values in this manner. Nicholas is getting $2,000, Thomas is getting $1,800, Jacob is getting $2,500, Jimmy is getting $3,000. So press Ctrl Enter. And now this is also going to give you the same result for us. Same result. Whatever you got using your names function, we are able to get the same result. There is no change. Now, what is the next thing I'm doing? I'm multiplying my salaries by a value called as 2. Multiplying salaries by a value called as 2. This is what I'm doing. Press Ctrl Enter. So now all the salaries have been multiplied by 2. So 2000 has been multiplied by 2, 4000, 1800 into 2, 2500 into 2, then 3000 into 2. So all the salaries have been multiplied by 2. So this is what we are getting. Now, we are creating one new vector, one new numeric vector I'm creating by the name of coefficients first. I'm creating this new numeric vector by the name of coefficients. And it is having the same length as your salary vector. It is having the same length as our salary vector. So let us try to create this. coefficients numeric vector. So now we have created this vector, coefficients. What is the length? How do you check length? Length. And then coefs. So length is 4. So length function you can use and you can find out what is the length of your vector. Now you are trying to multiply your salaries by your coefficients. This is what you are doing. So simply we can say salaries multiplied by coefficients. And after multiplying your salaries into coefficients, you are storing that result in a variable called salaries. So you are storing the result in a variable called salaries. So now if you press Control Enter, what is the result you are getting? 2000 into 2 is how much? 4000. Then 1800 into 1.5 is how much? 2700. Then 2500 into 1 is 2500. And then 3000 into 3 is 9000. So the same result you are getting. So this is a modified numeric vector. It is a modified numeric vector for us. So this is what we are getting. Modified numeric vector. Now, let us try to apply our square root functions. Yesterday we have seen on a single observation. Now if you have a list of observations, if you have a numeric vector, so what you can do? We are seeing my underscore vector is equal to, these are the values that we are having. Now when you say square root of my underscore vector, what is the answer you are going to get? 2, 4, 3. So it has taken the square root of 4, which is 2. It has taken the square root of 16, which is 4. It has taken the square root of 9, which is 3. So that result you are going to get. You are applying your square root function here. So apply that square root of my vector. So you are getting the same result what we thought, 2, 4, 2. So this is how your square root function can be applied on our numeric vectors. So that is what you can do. Now let us create another numeric vector and we are going to work out some small calculations. So let us try to do that. So we are creating a numeric vector with some values 10.5, 8, 7, 6, 15, 10, 8. So let us try to create one numeric vector. So we know how to find out the mean of these values. So we have discussed these concepts on a data set, but now we are discussing on vectors. So how you can do your small calculations. Let us try to understand. Mean of X. So press Control and 9.21. Then you can say median of X. So median is 8. So how do you find out your median? Simply arrange all the values in ascending or descending order. So 6, 7, 8, 8. Then I have 10. I have 10.5. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Then I'm missing one number here. 15. Okay. So now it is sorted. Now what is the median? Median is nothing but it is the middle value. So middle value in your data set is 8. So it is matching our answer. That is the median. So mode of X. So again, it is not able to give us the answer. So what is it you're supposed to do? Install our package modist. So if you see, if you go to packages, and then if I type modist, so you see there is a tick mark here against this package. So what is the meaning? We have already installed. We have already installed this package. So we don't have to install it again. So now what you can do, you can give library modist because you want to use that package. So give library modist. And then you can say MFV, most frequently occurring value. Then you have the mode of your data set is 8 because 8 is occurring 2 times for us. So that is the most frequently occurring value. So small functions we are applying here on our data. What are the other functions you can apply? Max of X. If you want to get the maximum value of X, you can say max of X. Press Control Enter. The maximum value in your numeric vector is 15 first. If you say min of X, minimum value in your numeric vector is 6. A range of X. What is the minimum value? What is the maximum value? If you give range of X, you are going to get what is the minimum value? What is the maximum value first? So ready-made functions, all these are ready-made functions, what we are using. Okay. All these are ready-made functions for us. So I think now you should be able to hear my voice. Okay. It should be good to go. So then a length function I'm using, length. So length is going to give me how many observations I have in my numeric vector. How many observations I have? 1, 2, 3, 4, 5, 6, 7. 7 observations I have in my numeric vector. So that is what is length. So you can apply this length function. We have seen many examples. So it is a useful function for us, length. Then sum function, it is going to take all the summation of all the elements in your numeric vector. So total sum of your numeric vector is 64.5. Then prod of x, it is going to take all the products of elements present in your x, prod of x. So this is the product. This is the product what we are getting. Product of all the elements in your numeric vector x. Then you can similarly apply standard deviation. You can apply variance. What is the definition of variance we have seen? Variance is nothing but a variety of information. So the more variety of information you have, the more variance that column is going to have. So more the variance, the more useful that column is going to be. So you can use that useful column for our analysis. So that is the advantage of variance. So what is the variance of x? Variance is 8.99. Then what is the standard deviation of x? Standard deviation is nothing but square root of variance first. So it is square root of variance. Variety of information, take the square root. It is going to give you standard deviation. So what is the standard deviation of your numeric vector? It is 2.998015. That is the standard deviation. And now, sorting function you can use. So how is our sorting function going to help us? Whether it is going to sort in ascending order or descending order, depending upon your choice. So I'm saying sort x comma decreasing is equal to true. So what is the meaning? You want to sort in the decreasing order. So it is going to sort everything in descending order for us. So press Control Enter here. So all the values have been sorted in a descending order for us. All the values have been sorted in descending order. Now if I change this to false, or if I don't say anything, let us not say anything. So now you see by default, even if you don't give any instruction, it is going to sort all the values in ascending order for us. It is going to sort all the values in ascending order by default. Now you can also explore this function, how sort function is going to work. So you can say sort decreasing is equal to false. So now let me go here. I can say decreasing is equal to false. Then everything is going to get sorted in the ascending order. So everything is getting sorted in the ascending order first. So whenever you are in doubt, whenever you want to know how to use any function, you are simply supposed to give question mark. Give question mark and try to explore that function. So this is what you are going to do. Give question mark and try to explore the function. So all these concepts, whatever we have discussed, they are important for us for doing small calculations. Now, next topic. So far, we have been working with vectors. Now, what is the next concept? Matrix. So, what is the definition of matrix? It is just like an Excel sheet for us. It is going to contain multiple rows and columns for us. So, imagine like a data set first. And then it is used to combine vectors. It can be used to combine your vectors with the same time. So I can combine my numeric vectors. That is what we have seen. And you can also combine your character vectors, your logical vectors, all these things you can do. So we are going to discuss them with the help of some examples. And matrices are used to store data in the form of a table. So you can use your matrix to store data in the form of a table first in R. So the rows of this matrix, so these are my rows and these are my columns. So rows of the matrix are generally observations. And then the columns are nothing but our variables. So all these columns, you are going to have your variables. So they are going to be your variable names, columns. So we have seen that MBA data set. So in that data set, if you see, these are all our rows. So we have 773 rows. And these are all our columns. So we have 3 columns. What are the names of my columns? Data serial number, and then work experience, and then Gmail. So these are all the columns that I have. Rows, comma, columns. So if you say dim stands for dimensions. Dimension functions first. So if I say dim in brackets MBA, what is the result you are going to get? You are going to get 773, comma, 3 columns. So that is the result. So this you are able to get on a data set what we have imported from outside. Imported from outside. Now, suppose if you want to create your own data, it is possible for us. For creating our own data, for creating our data in the matrix and doing some small calculations, it is possible for us. So that is what we are going to see. So matrix is nothing but it is going to have 2 dimensions for us. One is your rows, another is your columns. So it is used for storing the information in the form of a table. That is the overview, what you are supposed to do. So we are going to solve some examples using this matrix concept in few minutes. So this entire comment what we have written, they are going to help us understand the definition. So this is very important for us. Writing down the definitions are going to help you to understand what is the programmer trying to do with the code. you will be in a position to understand with the help of these comments. So now we are going to take a break here for 10 minutes. And then after the break, we are going to come back and we are going to continue our discussion on matrices. So take a break for 10 minutes. So let us continue our session. Matrices. We have to start from there. So now if you observe, what is the first thing we are doing is, we are creating our numeric vectors. So there is first numeric vector what I'm creating, it is called as column 1. Then I'm creating another column vector which is called as column 2. Then I'm creating another numeric vector called as column 3. So let us create these numeric vectors first. So column 1 numeric vector is created. Column 2 numeric vector is created. How do I know? From the right hand side, I am able to check the output. Column 1 numeric vector, column 2 numeric vector we have created. Then column 3 numeric vector also we are going to create. Then what is the function I'm using? I'm using cbind function. Column 1, column 2, column 3. So this is how you are going to bind them together in the form of columns. And you are going to store that result in a variable called my_data. You are going to store that result in a variable called my_data. So now we have successfully combined our columns together. And where is our data present? Our data is present here. So if you clearly look at what is the output, it is saying 1:5. That means you have successfully created 5 rows and 3 columns. So let us try to see the output. So we have created our 5 rows. That is what it is saying. Anything before comma, I told you. Anything before comma is rows. Anything after comma is columns. So 1:5 means I have 5 rows. 1:3 means I have 3 columns. So this is what we have to understand. So now this is my small matrix what I've created. So it is having 5 rows and 3 columns. So this is our small custom data what we have created. Custom data what we have created here. Now, suppose if I want to change my row names. So here you see, I have all these as my row names. Suppose if I want to insert new row names, I can simply use my row names function and I want to apply my row names on my matrix, which is called as my_data. And what are the row names I want to include? Row 1, row 2, row 3, row 4, row 5. Like this, I want to insert my row names. So press Control Enter. So now successfully our row names have changed. How do we confirm? Press Control Enter on your my_data. Now what is it you can observe? These are all our rows. These are all our rows and our row names have changed. Row 1, row 2, row 3, row 4, row 5. So in this manner, we are able to change our row names also. Now, some of the functions that you can use, especially when you are dealing with matrices and what are the C-bind function? It is going to combine your R objects by columns. It is going to combine your R vectors what you have created by columns. That is the function, column bind. A row bind function you have also. This is going to combine your R objects or vectors by rows. If you want to combine them using rows, then I can use my R bind function also I can use. Then row names function just now we have seen. To set your row names for your matrix, you can apply the concept of your row names. And then column names, you can also use it for setting your column names. So just like row names of my data, I can give call names of my underscore data. In the same manner, you can try and change your column names for your matrix. So all these functions we are going to use one by one. Then you can also use something called as transpose function. So what is the transpose definition? It is going to change your rows into columns, and it is going to change your columns into rows. This is what it is going to do. Changing your rows into columns and columns into rows. So now, see what is going to happen. You are saying transpose T, transpose of my underscore data. Press Control Enter. So now what has happened? You are having only 3 rows and you are having 5 columns. So clearly 5 cross 3, your dimension has become 3 cross 5. So 5 cross 3 matrix has become 3 cross 5 after taking the transpose. So this is what we have to understand. Another function is there called as transport function first. Now, let us try to use a function called as matrix function. So what is this matrix function going to do? It is going to create our matrix of data. So what are the parameters we are giving? We are giving data is equal to null value. That means inside my matrix, I want my data to be null value. And how many rows I want? N row means number of rows. N column means number of columns. So I want to have 1 row, 1 column. And I want this value to be null value. What are the other parameters that I'm giving? I'm giving by row is equal to false. What is the meaning of this? By row is equal to false. That means I want to fill the values, not by rows, by columns. So we'll try to understand this with the help of one simple example, and then you will be in a position to understand what this is doing. By row is equal to false. And what are these dim names? Dimension names. Do you want to give any row names and column names? I'm saying null. So what is the meaning? That means I don't want to give any row names and column names. I'm not interested in giving the row names and column names. So this is what you're doing. Now simply select this entire piece of code what you have written and press Ctrl Enter. So now you see your matrix has been created. So here data means what is the data you want to give? What is the data you want to provide? N row comma n column means number of rows comma number of columns. This is what I'm saying. Number of rows comma number of columns. So by default, by row is equal to false. Then what is the meaning? The matrix is filled by columns. So first it is going to fill columns. Column wise it is going to fill. Then row wise it is going to fill. That is the logic. Well, I'll take one simple example and I'll explain you. Then you will be in a position to understand what is happening. So for now, we are able to create one simple matrix in this manner using our matrix function. Now, observe this. Second example we have. I am saying create my matrix. Data is equal to 1, 2, 3, 11, 12, 13. Then number of rows, I want 2. Then number of columns, how many columns I want? 3. And then I'm saying by row is equal to true. That means I'm saying fill by rows first. First, completely fill my rows and then go for columns. What is the dimension names I'm giving? For my 2 rows, I want the name to be row 1 and row 2. For my 2 rows, I want the names to be row 1 and row 2 first. And then I want the column names to be C1, C2, C3. I want the column names to be C1, C2, C3. So let us try to create this and then let us try to understand what is happening. So select everything here, press Ctrl Enter. Now you give the matrix, what we have created. Now carefully observe what is happening here. Row 1, row 2 we have created. These are the names. Very good. Then again column names we have given C1, C2, C3. This is also very good for us. Then how is it filling? You observe. First it is going to fill all the rows. This is row 1 and this is row 2. It is going to come to next row. It is going to fill all your rows. So this is how it has created our matrix. Okay. Now, what is the next thing we are going to do is change this to false. Then observe what is the difference you are going to do. Let us change this to false. Now create our matrix and then check for the result. So now observe. How is it filling? It is filling our matrix column wise first. 1, 2, then 3, 11, 12, 13. So column wise, it is filling our matrix. So column wise, we are able to fill our matrix. That is the idea. That is the understanding what we are supposed to do. Now, so this is the definition of by row is equal to false, by row is equal to true. So simple concept. Now you will be in a position to do this. Now, if you want to explore any of the parameters, what is the simple thing you can do? Give question mark and you can give dimension names. Press Control Enter. It is going to give you what do you mean by dimension names. Okay, you can read through what is happening here. Now you can say list. You can also press question mark and it is going to give you examples of list first. So that is there. And now if you want to find out how many columns you have in your matrix, you can say n column my underscore data. You can say this. Then it is going to give you how many columns you have, 3 columns you have. So if you have forgotten our matrix, you can simply give the name of the matrix and you can again confirm your answer. So your matrix is having 3 columns first. Then you can give n row of my data. That means it is going to tell you how many rows you are having in your matrix. So we are having 5 rows. We are having 5 rows in our matrix. So this is what we can understand. 5 rows in our matrix. Then you can give dimension and my underscore data you can give. Then we are able to see that your matrix is having 2 dimensions for us. Rows is equal to 5 and then columns is equal to 3. So 5 comma 3, you are able to get the dimensions. So like this, you can apply all our functions. N columns, how many columns you have, n rows, how many rows you have, and then dimensions. How many rows and columns you have. So this is our own data, what we have created. This is our custom data, what we have created. So this is what we are supposed to understand. Custom data. Now, how can you subset your matrix? So we have seen how can you subset your vectors, but now we are going to discuss how can you subset your data from your matrix. Sometimes we want only some rows, some columns, only special values we want. So how are you going to do that? That is what we are going to see now. Selecting the required rows and columns from your matrix data. So before we get there, it is that time of the day, 8:30, where attendance link will be circulated. So all of you, try to fill in your details in the attendance sheet and then always come back and we are going to continue our discussion. So try to fill in your attendance sheet. It is already circulated. You'll be able to find it in your chat window. And then we'll be able to continue our discussion. So all of you do that. So get a subset of your matrix. That is what we are doing. So now select the row number 2, I'm saying. How are you going to select the row number 2? If you say my underscore data, and in brackets, if you give 2 comma blank, anything before comma stands for rows, anything after comma stands for columns. So 2 comma blank, if I'm saying, give me row number 2 and all our columns. This is what I'm saying. Give me row number 2 and I want all our columns. So I can press Control Enter. So this is what I'm getting. This is my row number 2. This is my row number 2. And it is giving me all these values present in all our columns. So present in a row number 2 and all our columns. That is what we are seeing. Suppose if I give 2 comma 1, then let us see what is the output going to be. It is going to give me the value which is present in row number 2 and column number 1. What is the value present? 6. So we are going to get the output as 6 first. So this is what we are going to get. We are going to get our output as 6. So that is how we are able to select our values based on your row number and column number. Based on your indexing, you are able to do this. Now suppose if I am selecting row number 2 to 4, how can I select that? Row number 2 to 4, I can simply say my underscore data, and then I can give 2:4, I can give like this. I can leave this empty blank here. So I'm saying I want row numbers 2, 3, and 4, and I want all my columns. So press Control Enter. So you are getting row number 2, 3, and 4, and you are getting all your columns. You are getting all your columns first. So that is what you're doing. Then, suppose if you want to select multiple rows which are not contiguous. What do you mean by that? Contiguous means side by side. So I want to select my rows which are not side by side. For example, I want rows 2 and 4, but not 3. So what is that you are going to do? You are going to say my underscore data and then C2 comma 4. You are going to give like this. So what is the output you are getting? You are going to get your row number 2 and 4, and you are going to get all the columns. So you have row number 2 and 4, and you have our 3 columns. So you are getting your non-contiguous rows. This is what you are getting. non-contiguous rows for us. Then if you want to see specific columns, then you can also mention like this. 1:2. If I mention like this, then it is going to give me my row number 2 and row number 4. And I'm going to get values corresponding to column 1 and column 2. I'm going to get values corresponding to column 1 and column 2 first. Now, so this is how we are subsetting our data, subsetting our matrix. So this is what we are doing. So these are some examples. Now you observe what is the difference in this example, what we have discussed, and this example. So if you see, I can refer to my columns either by their position. Either by their position, I can refer to my columns, or what I can do, I can also refer to my columns by their name. So you can write down these points. You can either subset your matrix by referring to the position of your observation, or you can refer to that observation by using their column name. So you are using column name now, which is 3. So I want my value which is present in row number 2 and column number 3, which is present in row number 2 and column number 3. So what is that value? Which is present in row number 2 and column 3 first. That value is 3. So you can either say like this, my underscore data, in brackets you can say 2, 3. Or you can say my underscore data 2, column 3. It is going to give you the same result. If you want, we can cross check also. So always remember, keep cross checking your answer. So you are getting the same result you are getting. There is no change. So that is the idea. So you can also try out some different examples. What is this example? My underscore data, and you are saying I want to select only column 2. So what is that we are doing? We are trying to only focus on all the rows for us. And I want only values corresponding to column 3, column 2, sorry. Here is column 2. So you have all the values. So that is how you are supposed to work out. All the values corresponding to column 2. Now, let us try to talk about how you can exclude your observations from your matrix. How you can exclude your observations from the matrix. So if I say my data, and in box brackets I'm seeing comma -1, that means what? I want to exclude my column 1. So remember, in your data sets also you can do this. Excluding your column 1, excluding whatever column you are not interested in, you can always do like this. So now our column 1 is gone. So now our column is gone. So that is how you are supposed to do. Your column 1 is gone. Now, so far we have been working on our matrices. Matrix. Now, let us discuss our data frame. So how to create our data frames? Let us try to understand. Let us try to understand this logic, how to create our data frames. So if you say my underscore friends, I'm just trying to check what is the output present here. My underscore friends. So you have Nicholas, Thomas, Jacob, and Jimmy. And friend underscore ages. What is the output you have? This is the output. Now observe what we are seeing. We are seeing a function called as data.frame. This is the function what we are adding here. And then in this data frame, I want the name to be coming from my underscore friends. I want age to be coming from friend underscore ages from here. And then I want height to be these numerical values for my friends. And I want their marital status from the logical vector what we have created. And I don't want any row names. I don't want any row names to my data frame, what I'm going to create. Now observe what is going to happen. Select everything. I told you we can select all the lines and you can execute the code. So now you are getting some error. What is this error? Why are you getting this error? So it is saying differing number of rows. So you have given 4 values here, but I'm having 5 observations here. So how to match? That is the question. It is not able to match. So what you're going to do, go back and try to rework on your vector friend underscore ages. So let us go back. Let us go back. Friend underscore ages. So now you have 4 observations. Now come down. And then let us try to execute the same command. Data.frame. So try to select all these commands and press Control. So now it is working. Because we have given 4 values. Now the code is working for us. It is perfectly fine. Code is working. And then try to check how it has created your data frame. So you see, there are no row names for us. There are no row names. You have Nicholas, Thomas, Jacob, and Jimmy. So I said I want my names. Then I said I want my age. Then I said I want my height. These values 180 centimeters, 170 centimeters, 185 centimeters, 169 centimeters. And then I want my marital status. So it is giving me true, false, false, true. So this is our data frame, what we have created. So this is our custom data frame, our custom data, what we have created. So previously we were working on data frames which were already ready for us. But now here you are creating your own custom data. And you can use this data for your analysis. You can create like this dummy data and you can work out some of the concepts that we have discussed, and you can practice those concepts. That is the idea. So it is always helpful for you to create these kind of examples and try to apply these examples. That is very important for us. So this is how you can create your own data frames for us. So what is the function we are using? We are using data.frame. So whenever you are in doubt, what is it you're supposed to do? Simply give question mark and write the name of your function. Data.frame. Simply write this. And then it is going to give you some explanation about our documents. So you can read through all these documentations. So always that is the best way of knowing how to apply any function in R. Give question mark and then you are supposed to say the name of the function. Then it is going to give you how are you supposed to write that function, what are the different parameters you are supposed to include in that function. All this information you will be getting. That is the logic. So now I'll show you something which we have not done before. That is, I'll show you a concept of how to import your Excel file from outside. So far, we have been working on how to import our CSV files. That is the knowledge what we have. Now what we are going to do is, let us try to import our file from the outside, and this time the file is going to be an Excel file for us. So I'm going to show that to you in R Studio Cloud. I'll show you. Okay. R Studio Cloud. Let us log in. So log in with Google and then log in. So now go to new project, select new R Studio project first. So just wait for a few seconds. So now the first thing what we have to do is click on this, select R script. So now how do we upload one Excel file? You observe what we are going to do. Click on upload here. Select choose a file. I'm going to select one file from here. Bahamian research. I'm selecting this file. And then I have the file uploaded on my cloud server now. Now go to import data set and you have to select from Excel. Okay, this is a new thing what we are doing from Excel. Click on this option. And now you observe what is happening. It is giving us information that you have to install some packages. What are the packages? Read Excel package and RCPP package. That is what it is telling us. And it is asking us Do you want to install these packages now? So say yes. That means for Excel file to be imported, you have to install some packages. What are those packages? You have to install read Excel. And then you have to say RCP package also you have to install. Okay, RCPP package. Now click on browse here. Then select Bahaman1.excelSX file. It is an Excel file for us. So the name of the file is Bahaman_1_. So you can change this file. You can change this file name. Okay. So in this code, if you see, if I change this file name, automatically in the code it is changing. So in the background, it is running this code for us. It is saying library, read Excel, and then it is saying a read_Excel function it is using, name of the file, and storing the contents of the file in Bahaman1. That is what it is doing. And then it is saying view Bahaman_1. So now this is our data set. So this is how our data set looking like. It is having two columns. One column is defective items. Another column is country. So now simply you can click on import. So successfully we have imported our Excel file. It is having 800 observations of two variables. So 800 entries are there and two variables are there. So if you scroll down, you will know what is your data. So all defective items data, I have country India, Sri Lanka, then I have Bangladesh. All these countries I have. Okay, China also is there. So that is how you are supposed to import your Excel files. And you can work out just like how you have applied our concepts in your .csv file. Same thing you can also do on your Excel file also. So it requires you to install some packages. You have to install read_Excel and RCPPP package. So these two packages you have to install, and then if you see at the bottom, there is the code what we have written. That means RStudio has written this code for us in the background, and this code is helping us for importing our Excel file. So again, I'll show you step by step. You follow what we are doing here. So first thing is, let me clear all these things. So now we are starting on a clean slate here. Upload, click on this option upload and select the file. Any Excel file you can select. Okay, I can select any Excel file. So this is CSV. Let us select Excel file, Bahaman. So this is your ExcelSX file. Click on OK. Now this file has been uploaded onto your cloud server. Now what you are going to do? Now you have to click on import data. Select from Excel. So now what is happening? It is not giving us those packages which are required because we have already installed, right? So let me again go to packages and let me check for read Excel. And then let me go for RCPP. So I am uninstalling these packages. So that is what I've done this now. Now, after we have uploaded this file, click on import, select from Excel. So now it is saying we have to install these packages, read Excel and RCPP. That is what we are supposed to do. Click on yes. So now it is installing our packages which are required. So after installing our packages, we have to select browse. Select the file here, Bahman, click on open. So now this is a data set. This is a background code. You can change the name. I can say just Bahman is enough for us. And click on import. And now we are able to upload your Excel file like this. You are able to upload your Excel file in this manner. Bahman first. Now, I'll share this file with you. You can also try that. So I'll share it in your chat window. And then you can also experiment of how to upload your Excel files. So that is a simple concept what we have done, uploading our Excel files. So far we have worked with our CSV files. You know how to upload them. And then we have also worked with our Excel files. You know also how to use them, how to import your Excel files and work on them. So today we have seen some interesting concepts. We have worked on your vectors and we have discussed the concept of matrices, how to create your matrix using the function. And then we have seen your data frame concepts, how to create your data frames, and lot of examples we have discussed on all these concepts: vectors, matrices, data frames, how to subset your vectors, how to subset your matrices, how to subset your data frames. So all these concepts we have seen. So it is a very useful exercise that we have practiced all these kind of concepts for us. So in the same manner, we are going to continue in our R discussion, and we'll try to discuss some more topics, some more interesting concepts, like how to visualize your data. We have not seen that, creating different types of visualizations, like histograms, box plots, what is the information that you can get. So all this visual analysis we are yet to do, we are yet to work out. So in the same manner, in our coming sessions, we are going to discuss these concepts. All these topics we are going to practice using our R Studio, and then we can try to apply with the help of some more examples. So let us break for the day here and then connect back tomorrow to resume our discussion. Till then, take care, stay safe. Thanks for your time today, and bye.